Okay, so review video number 1 from first period. In this video we'll have, what worksheet is this? Worksheet number 4. I'm going to do problems 2, 5, 8, 9, and 12. So that's the plan in first period. After that I'll be happy to take whatever questions you have in addition to those. So let's look at the review worksheet and go over a few of these. Number 2. Ladies, can you get this worksheet out? Number 2. If dy dt equals negative 2y, y equals 1 when t equals 0, find t when y equals 1/2. Okay, so that's a lot of information. T and y. T is 0, y is 1. Find t when y is 1/2. Okay, so I don't know that I have to put the information as a table, but that helps me kind of organize things. Separate variables, so dy over y equals negative 2 dt. I feel like we've done so many of these, I don't mind picking on people for help. So Mia, how about the left-hand side? When it's time to integrate dy over y, what do I get? Wait, we're looking at the left-hand side. I don't worry about the right. So just the antiderivative of dy over y. Okay, so remember this is where we start. Maybe you start thinking power rule. Increase the power by 1, divide by the new power, but that doesn't work. So that's the route that most people go down initially. And then they realize when it doesn't work, hopefully that triggers their brain that, does that help? Do you remember what the antiderivative of dy over y is? What was that? All right, somebody help her. What's the antiderivative of dy over y? Natural log. So natural log, absolute value of y equals negative. Anders, how about the right-hand side? What's the antiderivative of 2 dt?
Just negative 2t plus c.
Plus c. Good catch. Yes, got to have the plus c on there. So this is... well, Gregory, tell me, what do we want to do next?
The e thing.
The e thing, that's a perfectly good way to say it. The e thing, the loop-de-loop thing. E to the negative 2 plus c equals y. I've dropped the absolute value bars because e to anything is going to be positive, so we're not really worried about that. There's another, Joe, there's another algebra magic step that happens next.
You need the c before all?
You can put that c, I should be careful how we phrase that, because it's not the same c when you move it down front. You can put a different c down front. Now we can plug in our information. We like it when they give us a 0 because that usually makes things very easy to deal with. So c is 1. So y equals e to the negative 2t. So there's my solution to that problem, but the answer, the question they ask is, find t when y is 1/2. So 1/2 equals e to the negative 2t. Uh-oh, got some algebra. Calculus is easy. Algebra is hard. Lauren, what do you want to do to algebra our way toward an answer here? Good. Let's natural log both sides. So natural log 1/2 equals natural log e to the negative 2t. I'm starting to peek ahead. I don't see any natural log 1/2s, but I do see some natural log 2s, so I'm thinking I'm in the ballpark here. Natural log of e is 1. And then if I divide by negative 2, natural log of 1/2 divided by -2. Let's see. Now, does that match any of my answers? It's like kinda sorta.
You have to like mess around with the power rule to make 1/2 2 and negative.
Yep. So I'm going to put that -1/2 out front. Maybe that helps. So I can grab the negative, make it the exponent, and that would flip that over. Like 1/2 to the -1 would just be 2. So 1/2 natural log of 2 would be answer choice C. What a lot of stuff going on in that problem. Another one where there was one calculus step way back here, and then algebra, including some algebra tricky stuff to get to the final answer. But it's tricky stuff you've seen before, so expect to see it again. Number 5. If the derivative equals x squared, y squared, y equals 1, find y when x equals 2. Okay, this is kind of the same type problem. So dy over y squared equals x squared dx. Again, I don't know that you have to put it as a table, but maybe it helps. So the 0.11 we know, that'll help us find c. And then once we find c, we'll plug in 2 for x to figure out what y is. Alright, antiderivative both sides. This antiderivative on the left is really going to mess some people up because they're not going to change it. And they're going to say it's y cubed over 3 or y to the -3 or something. But if instead you take the time to write it as a power, then you can increase the power by 1, divide by the new power. Okay, so that's 1 over y. I'm going to move the negative over, equals negative x cubed over 3 plus c. And I suppose I could solve for y, but it might be easier just to mess with it as is. Like just start plugging things in. If I want to solve for y, I would need to flip both sides. But you got to flip the whole thing so you'd have 1 over all of this stuff. I think it's probably easier to just plug in 1, 1 and see what we get. So 1 over 1 equals negative 1/3 plus c. So that means that c equals 4/3. So 1 over y equals negative x cubed over 3 plus 4/3. Alright, well next let's plug in x equals 2 to figure out what y is. So 1 over y equals 8/3 plus 4/3. So 1 over y equals 12/3, also known as 4. So if 1 over y is 4, then that means y is 1/4. Man, it feels like this whole test deserves the calculus is easy, algebra is hard stamp. Right? Because here's another problem where one calculus step and a whole bunch of algebra steps. Uh-oh, did I mess something up? Yep. Is that what you were thinking? Same thing, Ian?
Yeah,
Where did the negative go? Where did the negative go? Let's see. So negative 8/3 plus 4/3 would be negative 4/3. And then if I flip that over, I get negative 3/4. which stands for choice D. Quite unintentionally, I earned the stamp on that one, right? I didn't mean to make a mistake, but I certainly did. Actually, it wasn't even an algebra mistake. It was just not copying down the negative sign over.
I'm also confused how you got the negative x cubed negative though.
How that became negative?
Yeah.
Way back over here, increase the power by 1, divide by the new power. And so to get rid of that negative, I multiplied both sides by -1. And since I didn't know what C was yet, C times -1 could still just be C. Number 8, calculator. So this would be on the Tuesday part of the test. Let's see if I've got a calculator up here I can use. I'll grab one in a minute. Number 8. Puppy weighs 2 pounds at birth. That sounds like t equals 0. And 3.5 pounds 2 months later. If the weight of the puppy during its first 6 months is increasing at a rate proportional to, so dw dt equals k times weight, then how much will the puppy weigh when it is 3 months old? Okay. So a word problem compared to the previous two, but kind of the same thing. Here's a differential equation. We'll need to separate, integrate, use the initial information, and then plug in for 3. It's multiple choice, but I don't know that any of those are all like close enough where I'm not ready to just rule any of those out. I don't think that would be a good pick or a good idea. So let's move the w over, move the dt over, integrate both sides. Again, should be rocking and rolling on the integration stuff on this. Ava, what's the antiderivative of dw over w? Natural log of w. Bryce, how about the antiderivative of k dt? kt plus c. Again, with the absolute value bars, but for this word problem, like w is the weight of a puppy, right? Like that's not going to be negative. That doesn't make sense. So if we didn't include them, that would be fine because your weight's always going to be positive. All right, we'll do the e thing. So w equals e to the kt plus c. Then we do that c trick, c e to the kt. By the way, our calculus is over. Now we're just doing algebra. So let's plug in 0, 2. How many times do I have to do this before I realize that the c is the initial value? So w equals 2e to the kt. Next, let's plug in 2, 3.5. Figure out what k is. Now I'm going to need a calculator here in a moment. Divide both sides by 2. Natural log both sides. Skipping steps because I'm running out of room. Grab a calculator here in a minute. Divide by 2. So I'm going to have a weird value for k, but weird values are fine, especially when we have a calculator. So Careful with parentheses. Natural log 3.5 divided by 2. Close parentheses. Divide that by 2. I don't even need to write that down because that's k. I can store that as k. So now my problem is set. Like I know that W equals 2e to the kt, and I know what k is, so I'm good. Now I just need to plug in 3. So W equals 2e to the 3k. K is not a variable anymore. K is a known constant. The calculator knows what it is. So 2e to the 3k. Plus is multiple choice, so I hopefully get one of my answers here. 4.63 is pretty close to 4.6. So there's my answer. Again, I hope you're keeping up with these. It's a lot of algebra. The calculus isn't bad. Obviously, you got to know the calculus, but you also got to be able to do all the algebra. All right, number 9. This is the one long question or free response question that we'll do together today. An increasing function f satisfies the differential equation this thing with initial condition f of 0 equals 1400. I don't know what my fascination is with table of values. It's, I don't know. To me, it's the easiest way to make sense of the information they give me, but I don't really need to do that. Use the line tangent to the graph at x equals 0 to approximate the value of f. Okay, we did that once yesterday. We're doing it again. That suggests we might need to make sure we know how to do this. Tangent line to the graph. So I need a point and a slope. So the point is at x equals 0. 0, 1400 is the point. The slope is, that's the same thing as dy dx. So I can just plug in y is 1400. 1400 minus 300. I'm thinking this would be a calculator problem, just to make your life a little easier. So 1100 divided by 25 is 44. So my slope is 44, or at least my slope at that point is 44. So y minus 1400 equals 44 times x minus 0. Approximate the value of f at 1/4. Okay, so plug in 1/4 for x. So 44 times 1/4. Move the 1400 over. So that would be 1411. That's approximately f of 1/4. Oops. Okay, f of 0 is 1400. If the slope is 44, then if we go over 1/4, we've moved up 11, so our new value is approximately 1411. Use the second derivative, or find the second derivative, and then we did this yesterday. Use that second derivative to tell if it's an overestimate or an underestimate, right? Because if it's concave down, then our lines are under the curve. Excuse me, the other way around. If it's concave up, our lines are under. If it's concave down, our lines are over. But I need to find the second derivative. Let's maybe distribute the 1/25th. I think that might make easier when it comes time to take a derivative. 300 over 25 would be 12. But it doesn't really matter because that's a constant and is going to go away. So the second derivative then the derivative of 1/25 y would be 1/25 dy dx. And the minus 12 will go away because the derivative of a constant is 0. Find the second derivative in terms of y. Okay, I've got the second derivative, but I don't have it in terms of y yet. This is a pretty common thing. I need to substitute dy dx in there. But we have an expression for dy dx. 1/25 y minus 300. Okay, I guess I could multiply 25 and 25, but I don't really want to do that. Now let's see if it's an over or an underestimate. So the second derivative at y equals 1400, that was our sort of starting point. 1/25 times 1/25 times 1100. I don't know what that is, but what's the only thing I care about that value? It's positive. So I can really just say equals positive. Okay, so now the logic comes in. Second derivative is positive. That means f is concave up. And if we're concave up, that means the tangent lines are below the curve. Again, this is not stuff I memorize. This is stuff I sketch out and think through. And if my tangent lines are below the curve, then that means my approximation is an underestimate. Pretty common question to ask you to find a tangent line, use it to get an approximation, take a second derivative, and then you figure out if your approximation is over or under. And lastly, find the particular solution. So that means actually do the problem here with that initial condition. So let's see, dy over y minus 300 equals 1/25 dx. Antiderivative both sides. Finally back to a calculus problem after all the algebra stuff. Leo, your side is a little bit tricky, maybe. Antiderivative of dy over y minus 300?
Would that just be natural log 1?
So you're on the right track. It's natural log of y minus 300. The long way around would be to say u equals y minus 300, and then du would be dy, and you'd be taking the integral of du over u. But if there's no sign changes, most people don't go through that. They realize it's, du is dy, so you can kind of figure it out. Again, absolute values is the technically correct thing to do. All of my y values, though, are more than 300, so I'm not really worried about it for this problem. Monty, how about the other side? Antiderivative of 1/25 dx? Good. And here we go for the, feels like 100th time. Do the e thing. Although we need to be careful because we'll get e to the 1/25 x plus c equals y minus 300. So that's maybe a little bit different. I'm going to do two things at once here. I'm going to move the 300 over, and I'm going to move that c down front. Alright, now let's use the initial condition. Be careful, c is not going to be 1400 for this problem, though. C is going to be 1100. So y equals 1100 e to the 125th x plus 300. Goodness. I mean, I say goodness, they're all the same. Separate, integrate, algebra, 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 algebra. But you've got to get the practice in, and you've got to know your integrals, because you're definitely going to see some natural logs show up. But the stuff on the right, sometimes it's simple, sometimes it's crazy. Got to know all the rules. All right, one more of my choosing, and then you can pick some if you like. Let's look at number 12. Speaking of knowing the rules. Consider the differential equation. dy dx equals that thing. What is the particular solution? So that means separate, integrate, and use the point it gives us. So dy over y equals dx over square root of 1 minus x squared. Okay, I'm not going to pull a popsicle stick for the right-hand side, because it's been a while since we've seen that. But the left-hand side, Kylie, definitely is a layup at this point. Good, natural log of y. Dangerous to call it a layup and then call on somebody in case they miss it. Right hand side, I'm not going to pick somebody because, man, we haven't seen that one in a while. Do you remember what that one is?
Arc sine. Is it arc sine?
It's arc sine. Everyone's like, oh, I haven't seen that in forever. Let's see. Derivative of arc tan was 1 over x squared plus 1. Derivative of arc sine was that one, 1 over square root of 1 minus x squared. So yeah, arc sine. Lovely. Arc sine of x plus c. I guess they were at least kind enough to not put any extra stuff in there where we had to use substitution and spawn things into the numerator, and it was at least a straightforward arc sine. Okay, next let's do the e thing. This is going to be a wild looking problem. E to the arc sine of x plus c. So then I'll put the c down front. What a lovely question that is. Given that the point goes through 1/2, 1. What? We don't even get a 0 to make our lives easy? So 1 goes in for y, 1/2 goes in for x. Come on. What's the arc sine of 1/2? That means find an angle whose sine is 1/2. Unit circle experts, pre-cal friends, pi over 6. So 1 equals c e to the pi over 6. What a wacky problem this is turning into. So c is divide both sides by e to the pi over 6. Alright, well I guess that's not great, but whatever, it's an answer. Okay, there could be different ways to write that. We could use some rules. I would stop there. But just in case it's multiple choice, let me review those rules. What's x to the 7th over x squared? X to the 5th. What'd you do? How'd you get this? How'd you get 5? Subtract. So I can subtract 7 and 2. I can subtract arcsine and pi over 6. So I could rewrite this as arcsine of x minus pi over 6. I probably wouldn't choose to write it that way, but if it's multiple choice, they might opt to clean it up like that. All right, lastly, what's the y-intercept? Hey, algebra friends, how do we find the y-intercept? Set x equal to 0. So I'm going to go with my first go with this thing. Oops, e to the arcsine of 0. That would be a safe stop, because all of that is calculator ready. But what's the arcsine of 0? What angle has a sine of 0? 0. And then e to the 0 is 1. And so it's a safe stop, but it sure looks a lot easier if you just rewrite it as 1 over e to the pi over 6. Yeah, that's a differential equations. Had to know the antiderivative that gets arcsine. Had to do a lot of algebra. Had to know a bunch of trig. Had more algebra. Hardest part of calculus is the first 12 years. Calculus is easy, algebra is hard. Like all those, you got to know all of the things leading up to do really well on the AP calculus test. Now you've seen some problems where it's like targeted calculus questions. You can get those right, but if you really want to make a 5, you need to be able to get it all in your brain. Okay, that's the ones I wanted to look at. I'll post videos of everything else later.